Good afternoon, math class. I am your math teacher, which is probably kind of cool because I'm not actually physically there with you today, but I want to talk to you guys a little bit about greatest common factor and least common multiple. So, greatest common factor is, come on, Mrs. Harrier, the highest number that divides exactly into two or more numbers. So, greatest common factor is sort of like, it's prime numbers, but it's the biggest number that fits into two or more numbers. So in order to do greatest common factor, we have to do this thing called prime factorization. So let's kind of break that vocab word down for ourselves real quick. So it has prime and it has factor in it. So a prime number, if you remember, is a number that can only be divided by one or itself. So for example, I have 7. You can only multiply 1 times 7 in order to get 7. Can you think of another example? I think the next example that I can think of is 13. If you can only multiply 1 times 13 in order to get 13. There are no other factors that you can multiply together in order to get 13. So, a factor. If you forget what a factor is, you can always look at the purple poster in our classroom. But a factor is a number multiplied with another number. So, in the expression 3 times 3, 3 and 3 are both factors. So, prime factorization then, so combining those two vocab words, prime factorization is breaking down numbers into prime factors. Mrs. Harrier, what in the world do you mean? So, let's do an example together. So the number 28. Right, the number 28. You can multiply two numbers together in order to get 28, right? So what two numbers would you use to multiply together in order to get 28? I used 4 times 7. Now, 4 times 7, we know 7 is a prime number, right? Because that was the one that I used in my example. But 4, you can still multiply things together in order to get 4. So 4 is not a prime number. What would you multiply together to get 4? Yeah, 2 times 2. So we dropped the 7 down to make our prime factorization tree. So we have 2 times 2 times 7. And then I have out to the side here a little 1, because if you multiply 1 times anything, you're going to get that number, right? So the prime factors for 28 are 1 times 2 times 2 times 7. Go ahead and multiply those out and see if you get 28. All right. So again, we need to be able to do prime factorization in order to do greatest common factor. Greatest common factor, though, is figured between two or more numbers, though. So we can do prime factorization trees, but usually we're going to be given two numbers in order to find greatest common factor. So let's use 28. And we're also going to use 36. So 28 we already did our tree for. So it's 2 times 2 times 7. Go ahead and try doing a factor tree for 36. You can pause so that you can try doing that on your own. So 36. You might have done your tree differently. You could have taken 6 times 6 to equal 36. I did 4 times 9, And of course, I know 2 times 2 is 4 and 3 times 3 is 9. I can't break 3 or 2 down any further. So in order to get greatest common factor, you're going to look at both of these. So what do 28 and 36 have in common? I've got the 2's underlined because 36 does not have a 7 and 28 does not have a 3. So the biggest number that both 28 and 36 have in common is 2. So 2 is the greatest common factor for 28 and 36. The next thing that we need to talk about is least common multiple. Least common multiple is the smallest multiple of 2 or more numbers. You might find that least common multiple is just slightly simpler than greatest common factor because it requires us to do something that we've been doing our whole lives, which is skip counting. So if you notice, least common multiple, again, is 2 or more numbers. So you need to be able to skip count with whatever numbers they give you. Our example are going to be the numbers 3 and 8. So I have 3 and 8 here. So we need to be able to skip count by 3s and skip count by 8s. So if you'll skip count with me, if we skip count with 3, we go 3, 6, 9, 12, 15, 18, 21, 24. So I've run out of room on my page, so I'm just going to leave it at that. 3, 6, 9, 12, 15, 18, 21, 24. So we counted by 3s up to 24. Okay, so now we're going to skip count with 8. So we start with 8. So then we go 8, 16, 24, 32, 40, 48, 56. So now I've run out of room on my page for 8s. So we skip counted and did 8, 16, 24, 32, 48, 56. So now we need to find the numbers that they have in common. So again, we've skip counted here. So we look, 3 and 8, not a match. 6 and 16, 9 and 24, 12 and 32, 15 and 40, 18 and 48, 21, 56. So what numbers do you see that they have in common down their list? I believe I am seeing 24 on 3 and 24 on 8 as well. So 24 is the least common multiple of 3 and 8. It's the smallest number that they can both be multiplied to get to. So what I want you guys to do today is I want you to go ahead and check your email. I've sent our math class some helpful links to help you with today's homework, which is all about greatest common factor and least common multiple. If you have trouble, you can always come back to this video or read more in those links in order to learn this skill. If you feel like you're still pretty confused, no worries, because we'll be talking about this again in class tomorrow. I hope you guys have a great day.